Hello students! Welcome to our third week of online class. In today's video, we are going to study about ordering fraction and finding the lowest common multiple. Are you ready to watch and listen to our discussion? But before that, let us read our words to learn. Number 1, greatest. Again, greatest. Number 2, lowest. Again, lowest. Number 3, ordering. Again, ordering. Number 4, comparing. Again, comparing. Number 5, finding. Again, finding. Very good. Now, in this video, you will watch the 2 topic. Please watch, focus, and enjoy. Thank you.
Finding the LCM using prime factorization. If we have to find the LCM of 12 and 32, we know we can list some multiples and find the smallest value common to both numbers. So multiples of 12, 12, 24, 36, 48, 60, 72, 84, 96, 108. And for 32, 32, 64 and 96. The LCM is 96. Now I'm going to use these same numbers to show you how to find the LCM using prime factorization. And the great thing about this method is it works for any number of any size. First, we do the prime factorization of each of the numbers. Primes in red and composite numbers in blue. 12 is from 2 times 6. 6 is from 2 times 3. Circle the primes. 32. 4 times 8 is 32. 4 is from 2 times 2. 8 is from 2 times 4 and 4 is from 2 times 2. Circle the primes. Next, we make a quick table of the prime factors. Using columns, we match the like factors. Leave a space where there's no match. 32 has the prime factor 2 5 times. Write them in. 12 has the prime factor 2 twice. I leave spaces and then put its remaining prime factor 3. I put a line under the prime factors to help my thinking. Finally, we find the prime factors of the LCM. We use one factor from every column, and if there's a vertical pair, we only take one of those factors. The LCM of these numbers is the product of these factors. 2 times 2 times 2 times 2 times 2 times 3. Work it out. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 times 3, well, 3 times 2 is 6, and 3 times 3 is 9, so the LCM of 12 and 32 is 96. And we know this is right because we already found the LCM using the multiple listing method. Now we know the method works, let's try a slightly more tricky pair. 28 and 35. First, find the prime factors of each number. 28 is from 4 times 7. 4 is from 2 times 2. Circle the primes. 35 is from 5 times 7, both prime. Next, we do the prime factors table. Match factors vertically, leave a space if there's no match. 28 is 2 times 2 times 7. 35 is 5 times 7. Now we get the prime factors of the LCM. 2 times 2 times 5 times 7. Finally, work out the value of the LCM. 2 times 2 is 4, times 5 is 20, times 7 is 140. You can see when you are given even bigger numbers, using the prime factorization method is going to be very helpful. Now here's a challenge for you. Using the method I just showed you, find the LCM of 15, 32 and 66. You can do it. When you've done, the more practice you do, the stronger your math muscles become. GCF is the partner to LCM. You have learned how to find the lowest common multiple. Now we learn how to find the greatest common factor. If you've practiced LCM and have used prime factorization to find it, then you are ready for GCF, which is also known as HCF or highest common factor. What is GCF? The greatest common factor is the largest value that divides exactly into 2 or more numbers. Let's explore it using a problem like you'll see in school. We'll find the LCM and the GCF of 36 and 44. First, we do the LCM. You know what to do. Get the prime factors. 36 is from 3 times 12. 12 is from 3 times 4. 4 is from 2 times 2. Then list the prime factors in a table. 2 times 2 times 3 times 3. Clear the area. 44 is from 4 times 11. 4 is from 2 times 2. Put those prime factors into the table, aligning like factors. 2 times 2 times 11. Now get the factors of our mystery LCM. 2 times 2 times 3 times 3 times 11. Work it out. 2 times 2 is 4, times 3 is 12, times 3 is 36, times 11. Well, 10 36s are 360, and add another 36 on, that makes 11 36s, is 396. That's our LCM. Now let's do the greatest common factor. If a prime factor is common to both the numbers listed, then it is used in our greatest common factor. 2 is in both lists of prime factors, here and here. 3 is not common, nor is 11. List the common factors, 2 and 2. Then we multiply the common prime factors to get the GCF. So 2 times 2, the GCF is 4. Isn't that easy? I think it's beautifully simple, and it's really fast after doing the LCM. If you use the prime factors table too to help organise yourself as you're working through, you're going to find it very clear and you'll be least likely to make a mistake. There's one last point you need to be aware of before you have a go at GCF for yourself. At some point, your teacher is going to give you a pair of numbers, a bit like this, where when you do the prime factorisation, you find that there are no prime factors that are common to the two numbers. So how do we list the GCF? If there are no factors common to the two numbers, then the GCF, the greatest common factor, is 1. Why? Because every number always has 1 as a factor. And now you are good to go on GCF. Check the